if you're given that they are zeros, -3 and 2 minus I, that also means that since 2 minus I is a zero, we have that 2 plus I must also be a zero just by the conjugate pairs theorem, which we just talked about. Okay, so we can then go ahead and write our polynomial as follows. We'll call this one f of x, and we'll have this equal to x plus 3. And that's because if you plugged in the -3, you'd get a zero here. And then we can have x minus 2 minus I. And then we can have x minus 2 plus I. Okay? Now here's kind of the trick with these. So if you want to go ahead and write these out, I would actually advise you, if you have two factors that include complex numbers, I would go ahead and factor these, or go ahead and FOIL these first, okay? And I'll show you why that works here in just a second. So let's go ahead and do that. We have the f of x is then going to be equal to x plus 3 times whatever the FOILed out product of these two are. So we're going to have x squared. Okay, so we'll have x squared minus x times 2 plus I. Okay, and then we'll again have minus x times 2 minus I. Okay, and then we'll have plus plus 2 plus I times 2 minus I. Okay, so let's go ahead and simplify everything inside of these parentheses here. Let's go ahead and simplify that. Okay, so we'll have x plus 3, and then let's go ahead and distribute everything. So we'll have x squared minus 2x minus xi. Okay, then we'll have minus 2x again, and then we'll have plus xi, because we'll have the negative x times the negative I, so plus xi. All right, and then we're going to have, over here, we're going to FOIL these out now. So we'll have plus 4, all right? And then we'll have minus 2i plus 2i, and then we'll have minus I squared. Okay, so let's keep going. So then we'll have this will be equal to x plus 3 times, once we collect all of our like terms, we'll get something a little bit simpler here. So let's do that now. So we have this xi, so this minus xi and this plus xi, those will go away. Okay, so we'll have x squared, looks like minus 4x here from this minus 2x and this minus 2x. Okay, and then we'll have plus 4. Okay, so, and then we'll have this minus 2i and this plus 2i, those will go away. All right, and then so then we'll have minus I squared. Okay, we can simplify that a little bit more. So x plus 3 times x squared minus 4x plus 4. And here, minus I squared, this is then going to be equal to minus a negative 1, because I squared is negative 1. Okay, so this will become x plus 3 times x squared minus 4x plus 4 minus a negative 1. So really it's plus 4 plus 1. So we'll have plus 5. Okay, cool. Everything looks good. So now what we can do is we can then, now that this looks a little bit simpler, we can go ahead and distribute these two and find out what the product is here. So we'll take this x to the x squared here, and we'll get x to the third. Then we'll take this x to this minus 4x, and we'll get minus 4x squared. Okay. Then we'll take this x to the 5, so we'll have plus 5x. Okay. Then we'll take the 3 to the x squared, so we'll get plus 3x squared. Then we'll take the 3 to the minus 4x, so we'll get minus 12x. And then we'll take the 3 to the 5, and we'll end up with plus 15 here. And now all we have to do is combine like terms. So we'll get x to the third, and we can combine the minus 4x and the 3x. So we'll get minus x squared. Minus 4x plus 3x is minus x squared. And then we have the 5x and the minus 12x, so we'll have minus 7x. And then we just have this plus 15 out here. And so now we know that this is our polynomial of degree 3, where we were given just 2 of the zeros. And we were able to find that using the conjugate pairs theorem. Okay, let's do a little bit harder of an example. Let's say we want to find a polynomial, which we're calling f of x, of degree 4 with the following zeros. We're given that 1, -4, and 1 minus I are all zeros of this polynomial. Okay, so because of the conjugate pairs theorem, that means that 1 plus I is also going to be one of the zeros. So we can write f of x as x minus 1, since 1 is a 0. We can write it as x plus 4, since -4 is a 0. We can write it as x minus 1 minus I. And then we can write it as x minus 1 plus I. All right, now remember, anytime you have two factors that have complex numbers in them, we're going to multiply those together first. So we're going to start by multiplying these two together and seeing what we get. So this is going to become x minus 1 times x plus 4. All right, and then we'll have x squared. All right, and then we'll have minus x times 1 plus I. Okay, and then we'll have minus x times 1 minus I. And then we'll have plus 1 minus I times 1 plus I. Okay, let's go ahead and simplify everything over there. All right, so we'll keep the x squared here. Everything looks good there. And then we're gonna distribute these x's here. So we'll have minus x minus xi. That's from distributing this here. And then we'll have minus x plus xi. Okay. And then we'll have plus 1 minus I times 1 plus I. Okay. All right, so now we can see if we can combine, we can go ahead and see if we can combine our like terms. So we'll have x minus 1 times x plus 4. And what we'll see here is this minus xi and this plus xi, those will go away. All right, so then we have minus x. So okay, here we're going to have x squared minus 2x then. We've taken care of those. All right. And then now what we have is we have plus 1 minus I times 1 plus I. So let's go ahead and FOIL these. So we have 1 times 1, so we'll have plus 1. Okay. Then we have 1 times I, so plus I. Then negative I times 1, so minus I. And then we have a minus I squared. Okay. So we can continue to simplify this. We have x minus 1 times x plus 4 times x squared minus 2x. Okay, the I and the negative I go away. And this minus I squared will become minus a negative 1, so plus 1. So we'll have 1 plus 1, which will give us plus 2. Which is great, because now what we can do is we can just go ahead and FOIL everything out like normal. We have a couple choices now. We can either go ahead and FOIL these two together, or we can distribute this x plus 4 into the x squared minus 2x plus 2, or we can distribute the x minus 1 into the x squared minus 2x plus 2. Really, it doesn't matter. It's up to you at this point. It should all get you to the same place. But so let's go ahead and just FOIL these two together. Keep it simple. So this will become x squared plus 4x minus x minus 4 times x squared minus 2x plus 2, and we can simplify this as x squared plus 3x minus 4 times x squared minus 2x plus 2. And then now what we can do is we can go ahead and distribute everything here. We can do the longer version of FOILing here. All right, so we have x squared times x squared. We get x to the fourth, okay? Then we go x squared to the minus 2x, so we get minus 2x to the third. And then if we keep doing this process, we'll get x squared times 2, so plus 2x squared. Then we do the 3x and distribute it to everything, so we'll get plus 3x to the third, okay? And then we'll get minus 6x squared because we take the 3x and the minus 2x. And then we'll get plus 6x. And then now we have to deal with this negative 4 and distribute it. So we'll have minus 4x squared plus 8x. That's from the negative 4 to the negative 2x. And then negative 4 times 2 is minus 8. And we can go ahead and combine all of our like terms. So we have, here we have x to the fourth. That's going to be all by itself here. And then we'll have minus 2x to the third plus 3x to the third. So we'll have plus x to the third. Okay, get rid of those, taking care of x to the fourth. Then we have 2x squared, and then we have minus 6x squared. So we have minus 4x squared. Okay. Oh, and we have another minus 4x squared. Sorry, I missed that one. So we have 2x squared minus 6x squared. Okay, so we have, that would be minus 4x squared minus another 4x squared will give us minus 8x squared. Okay. And then we have the 6x and the 8x, so we get plus 14x. And then we have minus 8 out here at the end. Okay. Really, this should have been minus, sorry about that, minus 8x squared. We can bring all this in. So there you go. That is how our degree 4 polynomial should look here, okay? Lots of steps to this, but one of the real takeaways here is the conjugate pairs theorem, and then also as you're simplifying all of this, you want to start with those. You really do want to start with those factors that have complex zeros. Okay, so there we go. That is a little bit on writing polynomials of certain degree given their zeros.